Hi everybody, I'm gregfishel. Welcome to bonus weather video number 1 for this week, and I finally decided what I wanted to talk about. I thought it might be fun to take a look at the general large-scale pattern in the atmosphere. Now, there are always daily variations as systems move across the globe, but there are large-scale patterns that are always identifiable, and that's what we want to look at today. So I'm going to go ahead and show you first a satellite image of the Western Hemisphere. And it'll show us a couple of interesting things. Number one, you can see these well-defined storms and counterclockwise circulations. Everything around lows is counterclockwise in the northern hemisphere and clockwise in the southern hemisphere. And then you see these clouds in here. This is along what we call the intertropical convergence zone. North of the equator, in general, in the tropics, you have northeasterly trade winds. And then south of the equator, you have southeasterly trade winds. And so the two come together right near this intertropical convergence zone, and you get showers and thunderstorms. And it oscillates back and forth depending on what season it is of the year. It more or less follows the sun. So when the sun is in the southern hemisphere, it's going to be a little farther south. And when it's in the northern hemisphere or over the northern hemisphere, then it's going to be a little bit farther north. About 30 degrees north and 30 degrees south latitude, we tend to have sinking motion on a large scale. And this is why places, even along the west coast of the United States, like San Diego, have a very, very dry climate. And you might think, well, gee, they got that big Pacific Ocean sitting out there. Why don't they get bombed all the time? And it's because the sinking motion, the air rises to the equator, goes northward, and then sinks at about 30 degrees north latitude. Same thing in the southern hemisphere, 30 degrees south latitude. And sinking motion produces warming and drying. And so it's very difficult to get significant rain at that latitude unless you have perhaps an El Nino season, when they do tend to get quite a bit of rain, at least for a few months in Southern California. So that's the large scale picture, okay? That in the tropics, the winds generally blow from east to west, and then from about 30 degrees north to about 60 degrees north or south, then that's where you have the prevailing westerlies. So let's go on ahead now and take a look at a surface isobar pattern, and this is from today, and we're up in here, and this is the front that came through here, brought us the cold air today, and here's the big high off to our west. But this goes all the way from, almost up to the North Pole, almost down to the South Pole here. And you see these sort of strings of low pressure areas in here. This is that intertropical convergence zone that you saw on the satellite picture, that when air converges, it goes up, and you tend to have lower pressures in those regions. So that shows up pretty nicely. And then once you start to get north, where there's a lot more isobars, this is the mid-latitudes, both here and down in here. And these systems are moving west to east. Now, to illustrate that west to east movement in the mid-latitudes, it is useful to take a look at the upper airflow, okay? Now, here I've got shaded in blue areas where the 500 millibar heights are falling. That usually happens, or always happens, ahead of the system. And then the heights rise, those are in red, as the system pulls away. So you can see these little couplets here, okay? Like here's the system right here, falls here, rises behind it, falls here, rises behind it, and even down in the southern hemisphere, the same thing. Falls ahead of it, rises behind it. And then in the middle, here in the tropical regions, there are very few height lines, okay? So there isn't a whole lot going on there, but there's still enough that you can make out some things. So let me put this into motion, and you'll be able to see these couplets, okay, these height fall and height rise patterns moving along from west to east in both the northern and southern hemisphere. And you might be asking yourself, well, I thought things were opposite in the southern hemisphere. Well, they are, in the sense that around highs, instead of it being clockwise, it's counterclockwise, and lows, instead of being counterclockwise, are clockwise. But the Coriolis force, which is caused by the Earth's rotation, actually deflects things to the right in the northern hemisphere and to the left in the southern hemisphere. So you end up getting prevailing westerlies both north and south of the equator. So you can see those systems moving along. Now, if you look real carefully here near the equator and up into the tropical regions, can you sort of make out that these systems are moving from east to west? And we see that all the time in the tropical season. Of course, with waves coming off the coast of Africa, and they all move from east to west, and they gradually gain latitude And when they get far enough north, then they start to border on those prevailing westerlies in the mid-latitudes, and that's what starts them to make the turn and then head back toward the east. And again, the same thing would happen in the southern hemisphere. So you can see the mid-latitude systems with those nice color couplets, if you will, moving along from west to east in both hemispheres, and then a lot less lines, if you will, in the tropics, but what there are of them are actually moving from east to west, and that shows up very, very clearly in this particular animation. Okay, so that's a little bit about how the atmosphere works on a global scale, again, with minor variations from day to day. That is the bonus weather video for this, let me see, I need to click up here. And there we go, there are the credits, and that's it. So, and by the way, that global satellite imagery was courtesy of NESDIS, N-E-S-D-I-S, which I'm trying to remember what that stands for. It's the National Environmental Satellite Division something. I don't know, I can't remember what the IS stands for, but it's a satellite division of NOAA, and they're the ones that produce that type of imagery, as you might expect. All right, folks, you have a wonderful Tuesday evening. We'll have another daily update tomorrow and another bonus video tomorrow as well. Hope you'll join me for both of those. In the meantime, have a great Tuesday evening, and we'll talk to you again tomorrow. See you later, everybody.